Here's one more short slideshow that should help you understand the idea of a sampling distribution. Imagine that this is a population of 5 people, and that each number is the person's age. So we have a 20-year-old, a 22-year-old, a 24-year-old, a 26-year-old, and a 28-year-old. And the mean age of this population is 24. So if you added the 5 ages and divided by 5, you would get the population mean of 24. Now let's imagine that I want to take a sample from this population and record the ages of the people in my sample. And maybe I want to take a sample of 2 people and record their ages. So I decide that I want to randomly select 2 people from the population. Well, imagine that there's a certain button I can press that creates all possible samples of 2 people and places each of those possible samples above its sample mean. So here's person 1 and person 2. They're a possible sample of 2 people. Person 1 and person 2 their ages are 20 and 22, so they have a sample mean of 21. That's why they're right here. So they're the sample with the lowest sample mean. That's why they're all the way down here. Person 4 and person 5 are also a possible sample that I might get. Their ages are 26 and 28. And the mean of their 2 ages is 27. If you added their 2 ages and divided by 2, you would get 27 right here. So these 2 people are the lowest sample in the sampling distribution because they have a mean of 21. These 2 people are the highest sample in the sampling distribution because they have a mean of 27. Now let's look at these 2 possible samples right here. Person 1 and person 4, their ages are 20 and 26, so they have a mean of 23. If you add 20 and 26 and divide by 2, you get 23. But person 2 and person 3, their ages are 22 and 24. They also have a mean of 23 because 22 plus 24 divided by 2 is 23. So here we have one possible sample with a mean of 23, and here we have another possible sample with a mean of 23. These 2 samples both have a mean of 24, and these 2 samples both have a mean of 25. So when I randomly select my sample of 2 people, one of these possible samples will end up being my actual sample. So maybe I end up selecting person 4 and person 5, and I end up recording their ages, and my sample mean ends up coming out to 27. And this ends up being my data set because I recorded the ages of those 2 people. So you can imagine a sampling distribution as kind of like a gumball machine where one gumball will end up falling and end up being your selected gumball. Now imagine that instead of selecting a sample of 2 people from the population, I want to select 3 people. So what I do is I press a button that says I would like a sample of 3 people, and then it sorts out all the samples into all possible samples of 3 people, all possible combinations that could be selected, and each one ends up being stacked above its sample mean. So here's one possible sample of 3 people, person 1, 2, and 3. Their ages are 20, 22, and 24, and those 3 people have a mean of 22. The mean of their 3 ages is 22. That's why this sample is above 22 right here. So they're the lowest possible sample. Person 3, person 4, and person 5, their ages are 24, 26, and 28. So they have a mean of 26. They're the highest possible sample in the sampling distribution. And when I randomly select a sample of 3 people, one of these samples will end up falling to be my actual sample that I actually select in my study. So maybe I end up selecting person 1, person 4, and person 5 to be my sample, and I record their ages, and my sample mean turns out to be 24.7. And this ends up being my data set that I've recorded from those 3 people. So this is just another quick demonstration to help you understand what a sampling distribution is.